In this module, you will learn about the classical concept of redox reactions and its related terms. Before we begin, let's look at a common chemical reaction, like the effect of water on iron. After a few days, we notice that the iron has rusted. The rusting of iron is an electrochemical process that begins with the transfer of electrons from iron to oxygen. A redox reaction is a type of electrochemical reaction where oxidation and reduction occur simultaneously. Redox is the short form for reduction and oxidation. In the earlier days, scientists came up with the classical concept of redox reactions. According to it, oxidation is defined as addition of oxygen or an electronegative element to a substance, or removal of hydrogen or an electropositive element from a substance. Reduction is the opposite of oxidation. Hence, reduction was defined as removal of oxygen or an electronegative element from a substance, or addition of hydrogen or an electropositive element to a substance. Thus, according to the classical concept, redox reactions can be illustrated as shown here. Let's look at some examples of redox reactions. Let's look at an example. Consider the common salt sodium chloride. Did you know sodium chloride is formed as a result of a redox reaction between sodium and chlorine? Let's understand how. Sodium is oxidized due to the addition of an electronegative element, chlorine. Simultaneously, chlorine is reduced because of the addition of an electropositive element, sodium. This proves that in a redox reaction, oxidation and reduction occur simultaneously. Did you know combustion is also a redox reaction? Here's a combustion reaction of a hydrocarbon, methane. We know that oxygen is required for combustion. Methane reacts with oxygen to give carbon dioxide and water. In this reaction, carbon is oxidized due to removal of hydrogen, and simultaneously, oxygen is reduced due to addition of hydrogen. In the final example, we will see a redox reaction between copper oxide and copper sulfide. Copper oxide reacts with copper sulfide to give copper and sulfur dioxide. In this reaction, oxygen, an electronegative element, is removed from copper oxide, and copper, an electropositive element, is removed from copper sulfide. According to the classical definition of oxidation, here are some examples of oxidation reactions. In the first equation, adding oxygen to magnesium gives us magnesium oxide. In the second equation, chlorine, an electronegative element, is added to magnesium. The result of this reaction is magnesium chloride. In the third equation, hydrogen is removed from methane, which is oxidized as carbon dioxide. The resultant product is carbon dioxide and water. In the fourth equation, potassium ferrocyanide reacts with hydrogen peroxide. Oxidation occurs due to the removal of electropositive element, potassium, from potassium ferrocyanide. According to the classical definition of reduction, here are some examples of reduction reactions. In the first equation, mercuric oxide on heating gets reduced and forms mercury and oxygen. In the second equation, when ferric chloride reacts with hydrogen, electronegative element, chlorine will be removed and ferrous chloride will be formed. In the third equation, by adding hydrogen to ethene, we get ethane. In the fourth equation, the reaction of mercuric chloride with stannic chloride produces mercurous chloride and stannic chloride. In this reaction, mercury, an electropositive element, is added to mercuric chloride. You have now reached the end of this module. In this module, you learned that in a redox reaction, oxidation and reduction occurs simultaneously. Oxidation reactions are those reactions which include addition of oxygen or an electronegative element to a substance, or removal of hydrogen or an electropositive element from a substance. Reduction reactions are those reactions which include removal of oxygen or an electronegative element from a substance, or addition of hydrogen or an electropositive element to a substance.